Okay, so far in the unit we introduced the idea of work and energy and how work and energy are related. In order to do work on something, we're applying a force and we're moving at a certain distance. And when we're doing that, it's actually transferring or transforming energy. So if we're lifting something above the Earth's surface, it's called gravitational potential energy. And if we're moving something horizontally and something's in motion, it's kinetic energy. And so now the introduction of power is really just an extension of all of that. Power, in the most simplest terms that I can think of, is basically just taking whatever type of energy you expended or transformed during an activity and seeing how long it takes you to do that. That's how we determine your power output. So if we know how much energy was involved in a certain situation that involved doing work on something, and we know how long it took, we just have to divide the amount of energy by time, and that tells us what our power is. So the power is really just the rate of doing work. So really all we've done here is we're taking the idea of work and energy, depending on what it is that we're doing, and dividing it by time. So this is what our formula looks like. It can look like two different things. We can have power equals energy divided by time. And that's the same thing because work and energy are related. It's the same thing as taking our work divided by time. Okay, so power, let's look at the first two. Energy is E is the energy in joules, measured in joules. T is measured in seconds, it's time. And power then, if we're dividing those two, is joules per second. And joules per second, another unit for that is a watt. So if you see on light bulbs, their power rating, so for instance a 60-watt light bulb, that's how much power they're rated for. So that's their power output. If they were 100% efficient at doing what they're doing, that's how many joules of energy per second that they can generate. And so yeah, the term watt was just named after a scientist, but really it is the joules per second. How many joules of energy per second can this electrical device generate? So let's look at how this applies to certain situations. So a cyclist transforms 2.7 times 10 to the 4 joules of energy in 3.0 minutes. What is the cyclist's power? So remember, let's start by writing what you know already. So we've got energy equals 2.7 times 10 to the 4 joules. And our time, you'll see, is given to us in minutes. And remember that the formula involves time in seconds. So anytime you see a unit that you know you need to convert that first before plugging it into your equation. So we need our time to be in seconds. There's 60 seconds in 1 minute. So if we multiply that by 60, we end up with 180 seconds. Is the same thing as 3 minutes. And so what we want to do is calculate the power of the cyclist. So the power output of the cyclist is his energy divided by time. And so we end up with 2.7 times 10 to the 4 divided by 180. Now remember, I'm just going to show you for entering scientific notation. So this is scientific notation, 2.7 times 10 to the 4. In your calculator, you can enter it just like this if you have a calculator with the exponent key. Or remember the long way of expanding this to a regular number. 2.7 times 10 to the 4 just means that we're moving the decimal 4 places to the right. 1, 2, 3, 4. And the remainder spots get filled with zeros. So our new decimal is here. So 2.7 times 10 to the 4 is the same thing as 27,000. Okay, so whatever you're most comfortable with. If you want to enter it in your calculator as this, because you have a calculator that does that, that's fine too. And so what we end up with as a final answer is 150 joules per second is the power output of this cyclist, and that's the same as 150 watts. Okay, now let's look at where we have a different type of energy that we can still calculate the power output for. So a 52 kilogram student climbs 3 meters up. So here's your key. Anything, remember, that we're lifting above the Earth's surface, we're working against gravity. So it's gravitational potential energy. And this student climbs this ladder in 4.7 seconds. So the first thing we need to do is figure out what the energy is, what type of energy or how much energy is being expended by lifting this mass up this high. So remember, we have mass equals 52 kilograms. And our height or distance moved is 3 meters. And our time is 4.7 seconds. So our gravitational potential energy is what we want first. So remember, this formula looks like this. Mass times gravity times height. So we have 52 times 9.8, which is gravity always, and our height is 3. And so we end up with a gravitational potential energy of 1,529 joules. And what we can do anytime we find out what the energy is, depending on what type, we can figure out what the power is by dividing it by the amount of time it took to do that activity. So this is how much energy it took, and this is the amount of time. Power is just our energy divided by time. So we end up with 1529 divided by our time in seconds, and we end up with a power output of 325 watts. And one last thing I'll show you, since we have a new formula here, because we have 3 variables in this formula, we can use the magic triangle again. So remember, we can only use it when we have 3 variables in a formula. In the last 2 formulas we learned, we couldn't fit it into a magic triangle because they had 4 variables, or they had a squared symbol on it. So this is what this magic triangle looks like. Energy over time, and P goes here. And remember, just cover up the variable you're solving for, and then you should be able to solve for any of the variables regardless of what they ask you. And that's it.